and 5.3 today, and that will end probability. So number one, according to my summary here for you, is the addition rule for disjoint or mutually exclusive events. Okay, before we even talk about the addition rule, we have to define what disjoint events are. Disjoint events. Sometimes, and it's the same thing, they are called mutually exclusive. Mutually exclusive events. So mathematicians and statisticians like Venn diagrams. Very easy way of presenting what you are talking about and analyzing it. So let's suppose we have 10 numbers. And they are from 0, 1, 2, ... 3, ... 9. 10 numbers. This is what it's called the sample space. Everything. That's all we have. So let's suppose we have two events, event E and event F. And we can put in anything you want. Let's say, I like this example from your text. And everything else is here. So 3, 4, 5, 6, and 7. So in one event, event E, consists of numbers 0, 1, and 2. Event F is like selecting 8 and 9. Everything else, all the other numbers between 3 and 7, are outside of these two events. So, talking about disjoint events or mutually exclusive, we realize that these do not have anything in common. So they have no common elements. So these two events do not have common outcomes. I caution you here, for mutually exclusive, we do not talk about probabilities. When discussing disjoint events. This is very important to understand. There is no reference to probabilities. We only say disjoint events do not have common outcomes. Do not have common outcomes. Period. And there is no discussion about probability. They do not have common outcomes. These two do not have common outcomes. What is the probability of event E? Now we talk about probabilities, but not based on the fact that they are disjoint or not. So, first of all, the probability of the sample space is 1. Is 1, for sure. But what's the probability of E? Is that all items are equally likely. So, if I get a 0 or 1 or 2, and I have 10 numbers, so there are 3 possibilities out of a total of 10 numbers. What is the probability for event F? There are 2 likely possibilities, in other words, 2 outcomes divided by 10. Yes, I will simplify this into 1 over 5. Now, what if we want to calculate what is called OR? There are 2 ways of writing this OR situation. And I prefer showing both, not just the one in your book. I'm not sure what I'm doing with this blank pages here. Okay. So if I want to determine the probability of E or F, or is normally denoted by union. I'm sure you remember this from algebra. So this is a much better way of presenting it, but it's pretty much the same. So either you write E or F, or E union F, same thing. So obviously, since the probability of this is 3 divided by 10, and the probability of F is 1, or let me put it as 2 divided by 10 better, because then I have to go back and add them up. And they have the same denominator, so it's 5 divided by 10, so this is 1/2. This happened because they do not have a common element at all. How will this look if they, E and F, were not mutually exclusive? For example, this is an example for non-mutually exclusive. Example for not disjoint. I don't know why I cannot put S before J. Disjoint today. This is still the sample size, the sample space, but here is E and here's F. So let's say 0, 1, and 2, and 8 and 9. I still have outside the 3, 4, 5, 6, and 7. But this time, E and F are not disjoint. Why? They have a common outcome. Common outcome is 2. They have a common outcome. The probability of E doesn't change. It's still 3/10. But now the probability of F is still 3/10, like this, but not 2/10 as it was. At this point, there is something called P of E and F. We normally write it like this. Intersection. This was a normal U, and this is an upside down U. This, the probability of E and F, is 1 outcome out of 10. So the intersection exists. They are not mutually exclusive, or they are not disjoint. Any questions? Okay, what we wrote up here is exactly what the addition rule for disjoint events represents. So we talked about disjoint, we talked about not disjoint or non-mutually exclusive events, and now we're going to put in the addition rule for disjoint events. So these here are not disjoint, but for the previous example, and let me write it again to make sure that it's not confusing. So here we have E, here we have F. We put 0, 1, and 2, and 8 and 9, and everything else as 3, 4, 5, 6, 7. And this is the sample space. So here, for disjoint events, the probability of of E or F is the probability of E plus the probability of F. So this is the probability of, or what it's called, the addition rule. The addition rule for probability of disjoint events. So now we have an example at the bottom of page, or second half of page 1. So let's take a look. We have a deck of cards. Deck of cards, for those who are not interested in playing cards, we have 52 cards in every deck of cards. We have 13 spades, 13 hearts, 13 diamonds, and 13 clubs. For those of you who don't remember or do not have any interest in playing cards again, there are in each deck of cards, there are 4 aces, 4 kings, 4 queens, 4 jacks, 4 tens, and so on and so forth, till 2. For a total of 52. So here's the first question for us. Find the probability that you select a king. The probability of selecting a king is based on the empirical, empirical or thinking. I'm not going to look at them. I know how many they are. I don't have to perform any experiment. The total number of kings is 4 out of the total number of cards, which is 52. When you simplify, you get 1 over 13. The probability that you select a king or a queen. Probability that we select a king or a queen. Because these two events are disjoint. I cannot select one card and at the same time select a king or a queen. Because of the intersection K and Q, king or queen, is 0, then the answer will be the probability of selecting a king plus the probability of selecting a queen. There is no difference because they are both 4 out of 52. So I will have, for this disjoint events, 1 over 13 plus 1 over 13, which ends up being 2 over 13. Any questions? No problem. Any questions?
You knocked your headphones off, huh?
Everything okay?
God bless you.
Good. Everyone okay?
Yeah,
Good.
everyone's okay. Just someone sneezed really hard that their headphones came off.
Okay, Lana, we cannot see you. Jesse, I cannot see you. I don't know who you are, where you're hiding. And Winston, I can't see you. Okay, moving on. What happens now if we do have non-mutually exclusive events, like in the situation I just presented here? Okay. So now coming back to this example, I'm going to copy it again. You don't have to go back to your previous page. Here's the sample space, everything that can happen. And I created another 1, 0, 1, and 2, and 8, and 9. And we have 3, 4, 5, 6, and 7. And this is E, and this is F. You can call them A and B. You can call them anything you like. Okay. So this time we want to determine the probability of an or E or F. So obviously the probability of E will give us 3 out of 10. If I add now the probability of F, this will give us another 3 out of 10. But because I counted the middle part twice, first of all I counted it in E, and second time I counted it in F, I now have to subtract it. So minus, how many are in here? How many outcomes? 1. Minus 1 out of 10. So this is the probability of non-mutually exclusive events. So we're going to write it after we calculate it. So it's 6 minus 1, which is 5, divided by 10, which is 1 divided by 2. So for non-mutually, see, we use both interchangeably, disjoint or non-mutually, or disjoint or mutually exclusive events. The probability of E or F is the probability of E plus the probability of F minus the probability of E and F. because it was counted twice here. So we have to subtract it once. So this is what goes here. The general addition rule is this. P of E or probability of E or F, probability of E plus the probability of F minus the probability of the intersection or the AND. And I meant to add this, and I edited it by hand. So I want now to determine, for the same example we had with the 52 cards, with a deck of cards, the probability of drawing a king or drawing a spade. So now probability of drawing a king or a spade. So that's our question. First, I will start by determining the probability of a king, which we already have calculated. It's 4 out of 52, 1 over 13. Now we have to determine the probability of a spade. And I wrote it here for you because, as I said, not everyone knows this. There are 13 spades in a deck of cards, so 13 divided by 52, which is 1 over 4. Now, there is a king that is also a spade. There are 4 kings total, but there is one that these two events are not mutually exclusive. There is one king that is also a spade. So we need to determine the probability of the intersection, this one. So the probability of K, a king, and a spade is 1 over 52. Only one spade that is also a king exists. Finally, we can determine this. Knowing that the king and spade, let's write that, I should have written it. Okay, and a spade are not disjoint. They are not mutually exclusive. So therefore, the probability of a king or, be very careful with these conjunctions, or a spade, because it makes a huge difference if this is and, will equal the probability of a king plus the probability of a spade minus the probability of a king and spade. So then, probability of a king, I'm going to put them all over 52 for simplicity. So the probability of a king, it was 4 divided by 52, plus the probability of a spade was 13 divided by 52, and minus the probability of a king and a spade at the same time was 1 over 52. I needed the same denominator for simplicity. So this is 17 minus 1, which is 16 divided by 52. I will simplify by 2 now, and I get 8 over, what do I get, 26, and I can simplify again by 4, I'm sorry, by 2, and I get 4 over 13. Yes, you can put in the calculator and determine an approximation. Where's my calculator? Here. So 16 if you want, or 4. 16 divided by 52, and you get 16 divided by 52. I cannot get 8. It's 30.76%, or you can write 0.3077. Yes.
Underneath the 8, does that say 26? Or is that supposed to say 52 for underneath the 8?
Okay, so 16 divided by 2 is 8. 52 divided by 2 is 26.
Okay, got it. I was confused. I was like...
I cannot simplify the numerator without simplifying the denominator. So if I divide the numerator by 2, I must divide the denominator by 2.
Got it.